Your brain weighs less than a watermelon, yet it consumes nearly a quarter of all the energy your body makes. Why does this small, silent organ burn like a furnace even while you sleep? Tonight on The Quiet Cosmos, we'll unravel one of biology's greatest mysteries. How can something so light demand so much? Why is the brain always hungry? What is it really doing with all that energy? Settle in. Let's dive inward into a world of fire, thought, and forgotten wonder. You carry it with you everywhere. It doesn't breathe, doesn't ache, it never flexes, never lifts a thing. Yet it burns more fuel than your muscles in motion, more energy than your heart in full flight. Your brain, just 2% of your body weight, demands 20% of your energy. But we rarely feel it. The heart thumps, the stomach growls, the muscles stretch and ache with use. But the brain? It whispers. Its hunger is quiet. Its fire is hidden. And because it does not scream for attention, we forget it is even there, working harder than anything else. This is the paradox of thought. Imagine holding a small candle in your hand. Its flame dances, soft and flickering. Now imagine 86 billion of them, each one burning, flickering, signaling, firing. That's your brain. A bonfire of electric potential. But unlike fire, it's not chaotic. It's precise. It's calculated. Every flicker of energy is a signal, a thought, a whisper of memory, or a spark of emotion. Every cell within it is both consuming and creating, converting oxygen and glucose into something more than heat into you. And still, even when you're lying down thinking of nothing, staring at the ceiling with eyes half closed, the fire keeps burning. Why? Why does the brain consume 20% of your energy even when you don't use it? Evolution is a miser. It does not waste. Every calorie we use is accounted for. Every trait we keep is paid for in full. So why would nature allow, even design, a brain that devours so much energy? Surely, something this expensive must be useful. Surely it must give us something extraordinary in return. And it does. But the answer is deeper than memory. It's deeper than problem solving. Deeper than anything measurable on a test. It lies in the cost of consciousness. Your brain isn't just a processor. It's not a hard drive. It's a living, pulsing, dreaming network of cells, alive with electricity and chemistry. Every second, it juggles 11 million bits of sensory input, memory encoding, and retrieval, emotional regulation, muscle coordination, temperature control, blood pressure management, imagination, self-awareness, inner dialogue. And much of it happens without your consent. Even now, as you listen, your brain is firing trillions of signals, parsing meaning, making predictions, storing phrases, discarding others, balancing the beat of your heart and the depth of your breath, even as you lay still. This is not passive. This is energy intensive. Consciousness is not free. Let's make it concrete. Your brain uses around 20 watts of power, about the same as a dim light bulb. That may not sound like much, but biologically it's massive. A newborn baby devotes over 50% of their energy to the brain. Even as adults, we are neurological engines. The brain consumes approximately 120 grams of glucose per day, approximately 3.5 milliliters of oxygen per minute, millions of ATP. Molecules per second per neuron. These are the biological equivalents of currency. Your brain is spending them every second just to keep you running. And here's the twist. It spends most of it just maintaining the default mode, your baseline sense of self. Not solving puzzles, not writing essays, just existing. Imagine you're sitting in silence, eyes closed. You are doing nothing, no phone, no movement, no talking. And yet your brain's energy use hardly drops. Why? Because even in rest, your mind is active, dreaming, wandering, replaying conversations, rewriting events, simulating futures. This is called the default mode network, a constellation of brain regions that activate when we are not focused on the outside world. It's where self-reflection, memory, creativity, and daydreaming live. It's also incredibly hungry. The quiet mind, it turns out, is one of the loudest in energy. Let's zoom out. In evolutionary terms, the brain is a gamble. For our species, it was a dangerous investment. Big brains are risky. They require more food, they slow down reproduction, require longer childhoods and extended caregiving. But the reward? Language, culture, abstract thought, technology, empathy, art, science, cosmos, the 20% energy cost gave us the stars. There is no off button. Even in sleep, the brain burns fuel. Even in coma, it consumes energy. Because life is not the absence of motion, it's the presence of pattern. And the brain is a pattern generator. It is always predicting, always simulating. Even dreams are a theater of organized noise. So this small, soft mass inside your skull, this gray jelly of fat, protein, and electricity, it must burn. It burns because you are always becoming. We rarely think of thinking as tiring. But mental fatigue is real. That fog after a long day, that drained feeling after emotional turmoil, it's not imaginary. Your brain has consumed its glucose stores. It needs rest, replenishment, and silence, just as muscles do. And sometimes, the most intellectual thing you can do, I sleep. So what are we? A 1.4 kilogram sponge of meat, wired with salt and potassium running on sugar and breath that burns like a furnace to think, to imagine, to love, to wonder, to make the meaning of stars. That's what 20% of your energy is doing. It's not just keeping you alive, it's making you you. Somewhere inside your skull, a storm of light is always unfolding, a quiet thunder, a flickering of signals. You never hear it, but it is you, thinking, feeling, being. We often imagine the brain like a computer. Neurons are processors, firing commands. But this metaphor, while useful, is also deeply wrong. A computer waits in silence until a key is pressed. But your brain is never silent, even when you sleep, even when you're unconscious. Even when your heart stops for a moment, the brain lingers, still glowing. It does not wait. It plays. It's like a symphony that never ends. Every neuron is an instrument. Every connection is a note, and the melody. It's the rhythm of thought powered by fire. You are electric. Your neurons are cells built to move charge, to harness energy, not in the form of force, but in the form of flow. Inside every neuron are ions, sodium, potassium, calcium, chloride. Outside is a carefully controlled sea of different charges. And across the neuron's membrane is a voltage. It's a literal electric potential, like a stretched rubber band. The membrane holds this tension, ready to release it in a burst. When a neuron fires a signal called an action potential, it's not shouting. It's not even speaking. It's singing in voltage. The signal travels down the axon, triggering the release of neurotransmitters at the synapse, and the song is passed to the next neuron. But this music isn't free to maintain the voltage across the membrane, to fire signals through axons, to recycle neurotransmitters, to reset ion gradients. After every signal, the brain burns fuel. Its currency. ATP, adenosine triphosphate. Every second. Your brain uses millions of ATP molecules per neuron. ATP is made in your brain's mitochondria, those tiny power plants inside your cells. But ATP doesn't come from nowhere. It comes from glucose sugar, broken down through cellular respiration. And glucose needs oxygen to be efficiently burned. This is why the brain is such a voracious consumer of both oxygen and glucose. It doesn't store much of either. It can't slow down. So it must be fed constantly. Even a few minutes of oxygen deprivation can cause irreversible brain damage. Because this organ, this symphony of electricity, is always on. It's easy to focus on neurons. They get the spotlight. But in the shadows are glial cells, the support staff of the brain. For every neuron, there are about 10 glial cells. They feed neurons clean waste strap axons in myelin to speed up signals, maintain homeostasis, help with communication, and even memory-glial cells manage the metabolic needs of neurons, regulating when and how glucose is delivered. In fact, one theory of the astrocyte neuron lactate shuttle suggests that glial cells help convert glucose into lactate, kind of brain-specific fuel. In this way, your brain is less like a network of wires and more like a living city pulsing with exchange, nourishment, and negotiation. Let's imagine a thought, not a big one, just a memory, a name, a face. Behind that single moment are thousands, possibly millions of neurons firing in complex patterns. Some signal directly, others inhibit, some strengthen pathways, others weaken them. Every bit of this activity consumes ATP, alters ion gradients, releases neurotransmitters, engages support cells, requires oxygen, produces heat. Hall. For a thought, now multiply that by the trillions of thoughts, perceptions, and decisions made each day, most of them unconsciously. This is why the brain is so hungry. It is not lazy. It is not idle. It is constantly alive, always learning, adjusting, calculating. Even silence takes effort. You might think muscles would consume more fuel. After all, they lift, move, pump, run. But when you are resting, your muscles are off. Your brain is not at rest. Your heart uses 9% of your energy, your liver, 27% your muscles, 20% your brain. 20% and sometimes more. The only organ that rivals the brain's hunger is the liver, because it too is processing fuel. But the liver does not think. I can't imagine. It does not create art or feel grief. The brain is using energy not just to survive, but to mean. Most energy in the brain is spent at synapses, the tiny gaps between neurons where communication occurs. Each time a signal reaches the end of a neuron, vesicles release neurotransmitters, calcium ions flood in receptors. On the next neuron bind these messengers, then everything resets for the next message. This whole process, chemical and electrical, is energy intensive, and it happens billions of times per second. This is where thinking happens, and this is why thinking burns. It might seem strange. Why not use slower signals? Why not rely only on chemistry? The answer is speed. Electrical signals travel fast, up to 120 meters per second. This allows you to react instantly to danger speak and listen in real time. Coordinate movement, think, sequentially predict the world, become aware. The where electricity gave rise to rapid internal time. It's what lets us be present in this breath, this thought, this now. The price of that speed is energy. Learning is not free. When you form a memory, your brain physically changes. Connections are strengthened or weakened. Proteins are made. Genes are expressed, glia are recruited, and all of this requires more energy than passive perception. This is why deep learning, the kind that stays, is exhausting. And why sleep, where memories are consolidated, is such a powerful restorer. The brain pays for learning. It always pays in glucose. All this metabolic activity generates something else. Heat. Your brain is warm. In fact, it runs at a slightly higher temperature than the rest of your body. That's why your head feels hot during fever. That's why thinking too much can feel like your head is on fire. This is not a metaphor. This is thermodynamics. Energy use equals entropy equals heat. The more your brain works, the more it must cool itself. That's why blood flow to the brain is so critical. Even the shape of your skull and the vascular system within it is designed to dissipate heat without disrupting thought. When glucose drops, the brain falters. You feel foggy, confused, weak, emotional, forgetful. This is hypoglycemia, the brain starved of its sugar. But even more subtle forms of depletion, emotional exhaustion, mental fatigue, long focus create cognitive drag. The brain doesn't shut down all at once. It simply slips, signals slow. Connections weaken. Noise increases until all that remains is the need to sleep. What makes the brain unique isn't just its energy use, it's what that energy is used for. Most organs use energy to pump, digest, contract. The brain uses it to simulate futures, generate language, feel remorse, construct identities, seek patterns, seek questions, listen to music, wonder about stars. No other organ burns for such strange, beautiful reasons. No other fire gives rise to the cosmos inside. The brain is not just a sponge or a circuit. It is a living symphony of fire, fueled by breath, sugar, and time. And every thought you've ever had, every name you remember, every love you've ever lost, is paid for in molecules. Next time you forget where you put your keys, or why you walked into a room, forgive your brain. The kid is busy keeping your entire universe lit. We like to imagine the brain as something we turn on. We say, I need to focus. I'm switching gears. I'm zoning out. I'm going blank. But these are illusions. Even when you're doing nothing, especially when you're doing nothing, your brain is most active in its own way. In fact, the brain at rest is not resting. It is rehearsing, replaying, reimagining, reweaving the tapestry of self. This network of quiet, inward activity has a name. The Default Mode Network, or DMN. The DMN is a constellation of brain regions, stretching across the medial prefrontal cortex, posterior cingulate cortex, and precuneus that become more active when we are not focusing on the outside world in moments of call in mind, wandering self, reflection, memory, recall, imagination, moral, judgments, social awareness, autobiographical storytelling. The DMN lights up, consuming vast amounts of metabolic energy. You're not solving a math problem. You're not writing code. You're just thinking of nothing. But the brain is choreographing a quiet ballet inside your head. Here's the paradox. Resting state brain activity accounts for up to 90 to 95% of the brain's energy use. Only a small percent is added when you engage in tasks. It's like a stage that's always lit, always running a rehearsal. Even when no audience is watching, that's because what we call nothing is actually everything. When you're doing nothing, you reflect on your past, possible futures, conversations, counterfactual, what if? Is predictive coding your brain simulating possible outcomes to prepare for life? So when you rest, you are not idle, you're rehearsing reality. The brain is a prediction machine. Its job is not to react, but to anticipate, to model the world in advance. And the best time to do this? When the external world quiets down, that's when the brain turns inward. This explains why ideas often arrive in the shower, why solutions appear during walks, why memories replay when you lie in bed. Meditation can be both peaceful and overwhelming. Mind abhors a vacuum, so when you stop distracting it, it speaks. This inner theater is expensive. The DMN burns glucose and oxygen at rates comparable to focused thinking. Because reflecting on the self, your fears, regrets, hopes, identities, is no small task. Some scientists believe self-consciousness is the true evolutionary leap. Not just tool use, it's not just speech, but the ability to imagine yourself imagining. And that power has a metabolic price. Even to imagine your past, your brain must simulate the people, the sounds, the consequences. It must light up entire neural networks. Memory is not stored, it is reconstructed. And reconstruction burns fuel. During rest, brain consolidates recent experiences into memory, connects abstract concepts, processes emotions from the darises. Beliefs updates your internal model of reality, regulates body systems, all of this, while you feel like you're doing nothing. It is the difference between a computer screen off and the processor. It's quietly downloading an update in the background still. But alive, daydreaming is often dismissed as a distraction. In school, at work, in life. But neuroscience says otherwise. The DMN is more active when you're lost in thought, fantasizing, visualizing. Possibilities, reconstructing your past, imagining alternate futures. These acts aren't wastes of time. They're the architecture of creativity. Albert Einstein often credited his greatest insights, not to logic, but daydreaming. So next time your mind drifts, don't yank it back. Let it wander. It may be building worlds. The brain has two large MCOS, posing systems, default mode network DMN, active during rest, and introspection, task positive. Network TPN active during focus and external attention. When one lights up, the other dims. They work like a neural seesaw. The TPN is about solving problems. The DMN is about solving you. The most powerful minds know when to switch. Focused work and focused stillness. Meditation isn't about stopping thought. It's about watching the default mode from a distance. And what does meditation do neurologically? Deactivates DMN over time, reduces self-referential chatter, increases Awareness of the present builds gray matter and the prefrontal cortex calms. The amygdala fear center changes the energy patterns of the resting brain, but even here, the brain never shuts off. It simply shifts how and where the energy flows. As wakefulness fades, your brain doesn't stop working. It enters its next mode of inward attention. Sleep. Sleep is not unconsciousness. It is another default state optimized for memory, emotional processing, and cleanup. During sleep, brainwaves slow from beta to alpha to delta synapses. Our prenatal cells clean metabolic waste. Lymphatic system flushes toxins, emotional. Memories are reprocessed and remand. The energy never stops, simply flows differently. From the spotlight of logic to the backstage of restoration. But this quiet fire has a shadow. An overactive DMN is linked to rumination, anxiety, depression, PTSD, chronic worry, obsessive thought loops. Because a mind that turns inward too often without anchor, without silence, can become a storm. And like any fire, too much energy in the wrong place burns. Stillness is misunderstood. It is not the absence of thought. It is the permission to observe it. To let the default mode unfold without judgment. Without control, the resting brain is not lazy. It is poetic. It's the space where memories turn into meaning, pain becomes understanding, the future rehearses itself, the soul catches up, and this is where you are formed. Not just in what you do, but in what you allow yourself to be. Every time you sit with yourself, you activate an ancient system. The DMN has been found in humans, monkeys, dogs, even rats. It is not just human. It is animal introspection, the ability to reflect on being, to know that you know, to remember that you felt, to sense that you are more than your reactions, and that awareness is not free. It is bought with molecules. It is paid for in breath. And it is the signature of something beyond instinct, something we might call soul. Millions of years ago, something strange happened. A creature with fragile limbs, weak teeth, and no claws grew a brain. Not just any brain, but one so hungry it would demand more energy than almost any other organ. We follow the slow fire of evolution. How nature took the risk of building something so costly, and what we became because of it. There's a strange truth in biology. The more intelligent the species, the more energy its brain demands. A cat's brain is 0.9% of its body mass at chimpanzees. Brain is approximately 2%. A human's brain is also approximately 2%, but it uses 20% of all energy and takes them. Estimates put that number even higher in childhood, up to 60%. Why would evolution choose to feed an organ that doesn't help us run faster or jump higher or fight harder? Because this organ did something else? It helped us imagine in 1995. The scientists Leslie Aiello and Peter Wheeler proposed a radical idea, the expensive tissue hypothesis. The concept was simple. If the brain uses more energy, something else must use less. And that something was the gut. Our ancient ancestors traded digestive complexity for neural power. They evolved smaller guts, more efficient calorie extraction, bigger brains, and this trade only worked because of one quiet revolution: fire. Fire changed everything. Before cooking, humans, like other primates, spent hours chewing raw food to extract limited calories. But cooked food requires less energy to digest, releases more calories, softens, fibers, digests pathogens. With fire, we could eat more in less time, digest faster, absorb more nutrients. Suddenly, we had energy to spare, and evolution found somewhere to spend it: the brain. Let's think like nature. Every calorie counts. Every trait has a cost, and the brain is expensive. It demands constant blood flow. It doesn't store much energy it cannot shut down. It takes years to mature it, requires decades of caregiving. It leaves us physically vulnerable. So why did this organ persist? Because the brain gave us one thing nature had never fully seen before: foresight. The ability to plan, simulate, strategize, and learn from others. Suddenly, survival wasn't just about strength. It was about storytelling. Our evolutionary history spans 7 million years, from Sahelanthropus chidensis to Australopithecus, to Homo habilis, to Homo erectus, and finally to us Homo sapiens. Each step brought bigger brains, more social behavior, more tool use, more fire, more symbolic thought, but evolution wasn't in a rush. It had to rewire the entire body economy the brain needed. Better blood supply, more oxygen, more fat insulation, better skull-shaped childbirth adaptations, longer childhoods. It was the most complex investment plan life had ever attempted, and it paid off. In awareness, a human child is born unfinished. Other animals walk within hours. We take a year. Why? Because we evolved such large brains that we must be born early, or the head won't fit through the birth canal, so we arrive incomplete, vulnerable, open, and for the first few years of life, the brain consumes over 50% of our energy. It grows, prunes, rewires, millions of connections per second. We require years of protection, but in return, we gain plasticity, the ability to learn anything. A helpless infant becomes a language user, an empath, a mathematician, a dreamer. This is the cost and beauty of the human brain. Brains didn't evolve in isolation. They evolved in tribes, in early humans. Survival depended on reading expressions, predicting emotions, building alliances, teaching, storytelling, memory of others' actions. The bigger our social groups became, the more brain power was required to navigate them. This led to the social brain hypothesis, the idea that intelligence evolved to manage relationships. In essence, your brain is not just for thinking, it is for feeling together. And that is energy-intensive. No. Other animals speak like we do. Language is the most expensive tool ever evolved. It requires symbolic representation, syntax shared, context working, memory fine, motor control, predictive modeling. Every sentence you speak is a cognitive ballet rehearsed in real time by thousands of brain regions. And yet, we do it effortlessly. The energy cost of language is immense, but the evolutionary reward, knowledge, transmission, intergenerational memory, civilization, all built on the backs of words. Humans have the longest developmental period of any species. Not because we're slow, but because we're flexible. The brain remains plastic for decades, allowing us to adapt to new cultures, learn multiple languages, change beliefs, reflect on abstract truths. Other species are born knowing what they need. We are born ready to learn everything. This openness is energetically expensive, but it's also what makes us human, to fuel our energy-hungry brains. Evolution gave us another adaptation: fat. Humans carry more body fat than almost any other primate, especially infants. This acts as a metabolic reserve, feeding the brain when food is scarce, even in famine. The brain is protected first, because evolution knows if the brain dies, the species dies. So we are built to guard it, to feed it before all else. Other species could have evolved brains like ours, but most didn't, because the risk was too high. Big brains mean long dependency, high energy demand, fewer offspring, longer gestation, greater risk of death in childbirth unless the environment supports it with food, stability, cooperation. A large brain is a liability. But for us, the conditions aligned: fire, food, tribe, imagination. And so evolution gambled and won. If you were designing an energy budget for the human body, it would look strange. Brain gives 20%, heart gives 9%, lungs gives 5%, muscles gives 20% at rest, more when active, liver, kidneys, gut gives 45%. The brain is an outlier. It's smaller than a grapefruit, but burns through 1 in every 5 calories you eat. And for what? To imagine, to remember, to regret, to ask why? No other species uses energy this way. The brain gave us the stars. It gave us mathematics, maps, religion or morality, hope, grief, fand. The ability to wonder why we wonder, and this entire miracle came from burning glucose. We are made of fire and foresight, breath and biology, dreams and metabolism. We are nature's most extravagant bet. A baby is born with almost no memories. Number, language, no logic. Just need, reflex, breath, light. And yet, the brain is already burning. In those first few weeks, an infant's brain consumes over 60% of the body's energy. This is not for movement, not for learning facts, but for building the scaffolding of self. You are not born with a finished mind. You were born with a forest of untamed potential ready to grow. Prune and rewire. That growth requires fire. No other species devotes as much energy to brain development as humans. By age 4, the brain reaches 90% of its adult volume synapses form. At a rate of 1 million per second, gray matter thickens, white matter begins to insulate pathways. The energy cost is staggering at its peak. The child's brain uses twice the glucose per gram as the adult brain. This isn't waste, it's investment. Each connection is a possibility. Each firing is a rehearsal. Each moment is a construction of future thought. Inside the developing brain, synapses are overproduced far more than are needed. Why? Because the brain doesn't know what it will need yet. It creates a vast neural landscape, then prunes it based on experience, environment, emotionally tensioned. Culture, this process experience dependent. Pruning sculpts your identity. You are not born as you are grown. And energy fuels every branch. Not all learning windows stay open forever. Language, vision, emotion, regulation, social cues. Motor skills. Each has a critical period, a span during which the brain is maximally plastic. Miss that window, and some abilities become impossible to develop fully. Why? Because the brain saves energy. It cannot keep every window open. It must choose. And once the pruning is done, the door closes behind you. Humans are unique in another way. We take longer to grow up. Longer childhood, later puberty, delayed independence. Why? Because the brain demands time to wire itself through interaction. In play and touch, in story. In mimicry, the brain learns not just facts, but relationships, emotions, contexts, languages. This takes years of energy. Years of scaffolding, years of trial and error, and without it, we would not become fully human. Between ages 2 and 6, something astonishing happens. A child learns approximately 10 new words per day, grasps grammar. Without instruction, begins abstract thought, develops. Inner speech forms autobiographical memory. This is not just learning. It's a rewiring of time. Language lets the brain represent. Past future fiction, emotion, belief, and it consumes vast amounts of energy, but gives back culture, storytelling, and civilization. The young brain is wired for feeling before thinking. The limbic system, which processes fear, attachment, pleasure, and empathy, develops earlier than the prefrontal cortex. So a child feels deeply before they can explain. This is not weakness, it's biology. Energy flows first to survival, then to bonding, then slowly to reflection, empathy, tantrums, wonder. Fear, all are signs of a brain in formation, and all are metabolically alive. Children learn by watching, not just by doing. Their brains are packed with mirror neurons, cells that fire when observing another person's action or emotion. When a child sees you smile, their brain rehearses that smile. When they hear you speak, their neurons echo your voice. This is how children learn languages without being taught. Absorb emotional tones, mimic cultural behaviors. It's the brain becoming social, and it is incredibly energy demanding. A child sleeps more than an adult, and for good reason. During sleep, synapses are reinforced memories. Our consolidated growth hormone is released. Brain connections are strengthened. Emotional events are processed. Sleep is not a break. It is a workshop, and the growing brain needs this time to sort itself. Miss sleep, and development suffers. The fuel must burn clean. Metacognition, the awareness of your own thinking, comes later. But before that, children learn how to learn. Through trial and error, curiosity, sensory play, repetition, mistakes, every laugh, Every question, all of it, is the brain mapping its own terrain, and all of it requires metabolic support, the fire behind every wonder, because of the energy cost. The brain is selective. The early environment doesn't just shape behavior, it shapes the physical structure of the brain. Neglect can shrink brain regions, stress can alter hormonal circuits, enrichment can build neural density, love and safety can wire resilience. Every touch, every sound, every moment is absorbed into the neural blueprint. Do not remember our first years, but they remember us. The miracle of childhood is plasticity, the ability of the brain to change in response to experience. And while this declines with age, it never fully ends. We carry echoes of childhood, plasticity throughout life. It is what allows healing language, learning new habits, recovery from trauma, emotional growth, but the most radical version of it belongs to the child. A small body, a quiet flame, building futures. Such rapid development is not without danger. The growing brain is sensitive to toxins, vulnerable to malnutrition, reactive, too trauma-dependent on safety. It burns fast, but must be fed wisely. Nutrition, sleep, love, language, play. These are not luxuries. They are neural fuel, and without them, potential becomes silence. So what is childhood? It is not just a phase. It is not just waiting to become something. It is becoming itself. Every question asked, every emotion was felt, every silly story is told, every nap, every tear, every step was part of a sacred fire transforming biology into mind. We were all once sparks, and somehow we survived the burn. Sleep seems like nothing. No movement, no speech, no planning. Just rest, but inside the brain. Sleep is a metabolic symphony. It does not shut down, it shifts. New waves emerge, memories, replay neurons, synchronize fluids, circulate dreams, unfold. And it's the energy use only drops slightly by about 15%. Sometimes it even spikes. Sleep is not an escape. It's recalibration. Sleep isn't one state. It's a cycle of stages, each with its own brain rhythms. Stage 1, light sleep. The gateway. Stage 2, memory begins to encode. Stage 3, slow wave sleep. The deepest rest. EM. Rapid eye movement, where dreams live. Each stage plays a role, which demands energy. During REM, the brain's energy use rivals wakefulness. In some areas, like the visual cortex, it exceeds it. You may not move, but your mind dances. Dreams are not nonsense. They are the brain's attempt to process emotions, integrate memories, test predictions, simulate experiences, rehearse future challenges. In REM, the limbic system emotion is active. The prefrontal cortex logic is quiet. The result? A surreal world, powered by feelings and fragments. But this world requires fuel. Dreams cost glucose. They cost oxygen. They cost blood flow. Because dreaming is doing without consequence. If sleep were useless, evolution would have deleted it. But sleep is ancient, older than language, older than tools. Even insects show sleep-like states. Even plants have circadian rhythms because rest is not optional. It is where life refreshes its core in humans. Sleep clears metabolic wastery, sets emotional regulation, boosts immunity, repairs, cells prunes, neural connections, consolidates memory, all while the brain keeps glowing in the dark. During sleep, a system activates that's 10x more active than when you're awake, the glymphatic system. A network that flushes out waste from the brain using cerebrospinal fluid. It removes beta amyloid linked to Alzheimer's. Damaged proteins, neurexton spuiacide. Of high-energy thinking, imagine cleaning a city while the lights are dim. That's sleep. It's not just peaceful. It's necessary maintenance. And it burns energy to save energy. You study, you experience, you feel. And then you sleep. That's when your brain strengthens, important memories weakens, irrelevant ones integrates new learning. With old knowledge compresses and reorganizes information links. Emotional experiences to context. Sleep is when knowledge becomes wisdom. It is the final stage of learning, and energy flows through this process like a quiet river recarving its banks. Some scientists believe dreams evolved as threat simulations. You dream of falling, being chased, losing someone. These aren't random. They are neural rehearsals, safe tests of danger, practice for real life. Other theories suggest dreams are emotional detox narrative, rehearsal creativity boosters, but in all cases, they require conscious-like activity in unconscious states. The dream brain imagines itself, and that costs energy. Miss a night of sleep, and the brain changes. Attention declines, memory fades, motions, spike reaction, time slows, hallucinations can emerge. Why? Because the brain didn't get time to reset neurotransmitters process, inflammation, clean debris repair, network sleep deprivation, mimics brain injury, and the system struggles to keep energy flowing efficiently. Sleep is not rest for the brain. It is restoration. Even when awake, the brain dreams, daydreaming, visualization, fantasy, fiction. These are all modes of simulated reality. You imagine futures conversations, outcomes worlds that don't exist, the default mode network, which governs. Introspection overlaps with imagination centers. This is why creativity feels dreamlike, and why fiction feels real. The brain is a simulation engine, and it runs constantly. Fuel is required, even to pretend. When you zone out, you don't shut down. You rehearse conversations, predict social outcomes, solve. Moral dilemmas run, past regrets construct new ideas. The resting brain is deeply active. It draws on memory, emotion, language, and vision, and it burns fuel the whole time. Imagination is not fluffy. It's metabolically serious. Lucid dreams, where you become aware you're dreaming, are a special case. Here, self-awareness, agency, and metacognition emerge inside REM sleep, brain scans show. Increased prefrontal activation, high sensory vividness, logical. Awareness inside surreal content. This is consciousness nested inside unconsciousness, a rare, high-energy state. And it shows how flexible the brain's architecture really is. Nightmares feel worse than real danger. Because during dreams, logical filters are off, emotional circuits are high, you can't escape, but nightmares serve a function. They may process trauma, prepare for threats, rewire emotional memories like fire drills in a school. They feel scary, but they build preparedness. And even these terrifying dreams require energy to heal. Even when you sleep, the universe continues, and your brain must monitor the body, regulate. Heartbeat, adjust hormones, track breathing, maintain core temperature, asterisk. These autonomic processes are largely unconscious, but the brain controls them all, even in the depths of REM. It is not a light switch. It is a lighthouse always scanning when you sleep. Imagine this. Your brain is running simulations, cleaning its streets, filing, memories healing, emotional wounds practicing. Tomorrow dreaming new worlds. This is not passive. It is a night-long ceremony of metabolic precision. The work is quiet, but it is everything. Thinking feels weightless, but that's a lie. Each thought activates vast neural networks, fires electrochemical signals, balances inhibitory and excitatory flow, consumes oxygen and glucose, is built on memory, tension, prediction, and emotion. You don't feel the effort because the system is efficient, not cheap. Like a machine humming quietly beneath a floorboard, a single neuron fires a signal in milliseconds. But to do so, it requires a reset of ion gradients, ATP energy, to fuel sodium potassium. Pumps constant blood supplemental time, chemical release, and uptake. Multiply this by 86 billion. Neurons each connecting to thousands of others, and a single thought becomes a storm. The energy cost? Up to 20 watts, about the power of a light bulb. It's running nonstop, but with much higher stakes. Not all thoughts are equal. Some feel light. Others are exhausting. This depends on cognitive load. How many concepts you're juggling, emotional weight. Fear, regret, grief equals high energy novelty. New problems require more energy than routine ones working memory use. Holding information in the mind while processing it tinner. Conflict. Two competing ideas burn more than one aligned thought thinking. Isn't just noticing, it's constructing, and construction takes calories. Focus is metabolic discipline. To pay attention, your brain must suppress distractions, stabilize task networks, maintain working memory, activate top-down control via the prefrontal cortex, sustain it all in real-time. This requires high levels of glucose and oxygen. Studies show people performing demanding tasks consume more brain fuel. Mental fatigue corresponds with declines in glucose levels. This is why intense focus often leads to eye strain, headaches, irritability, craving for sugar. The mind is burning through its fuel tank. Every choice you make consumes cognitive energy, tiny or large. What to eat, what to wear, what to say, what to believe. This phenomenon is called decision fatigue. Eventually, the quality of decisions declines. We become impulsive. We delay action. We fall into patterns. Judges, even chess players, all show declining performance as decisions stack up. Thinking has a price, and sometimes the price is mental depletion. The same neural circuits used for analysis can trap us in loops. Rumination, worry, anxiety, these burn energy without forward motion. It's like revving an engine in neutral sound, heat and stress but no movement. The default mode network becomes overactive, emotions hijack logic. The body tenses as if in danger, and the more we try to think our way out, the deeper we dig. This isn't weakness, it's cognitive overload, and energy is the first to go. Despite the cost, we love to think, because successful thinking, like solving a puzzle, activates the dopamine system, the reward network areas linked to pleasure. Novelty and control. Solving problems is evolution's way of reinforcing this energy was well spent. It's why curiosity feels like hunger, and answers feel like food. But it's still expensive. The glow of insight is paid for in glucose. Not all energy goes to thoughts. The brain decides what deserves fuel, what's relevant, what's urgent, what aligns with goals. It filters incoming stimuli, matches it against stored models, and allocates energy accordingly. This system, the salience network, manages limited cognitive resources, and like a budget officer, it can say no. This is why your brain sometimes refuses to think, shutting down when it's overwhelmed to protect itself. Mental effort isn't confined to the brain. It impacts the heart rate, blood pressures, hormones, immune function. The body responds to cognitive load as if preparing for a challenge. Over time, this can manifest as fatigue, digestive issues, sleep disruption, emotional burnout. Your thoughts don't stay in your head. They ripple through everything, and they cost everything. Mindfulness is the act of observing thought rather than becoming it. This changes energy use, shifting from the default mode network to task-positive networks, reducing necessary ruminations. Efficiency and emotional regulation. Meditation has been shown to lower glucose use in overactive brain regions, enhance focus with less effort, slow resting metabolic rate. By not engaging every thought, the brain uses less energy to do more. Stillness is strategic. You stare out the window. It's no goal, no input, no plan, but this isn't nothing. It's diffuse mode, thinking a state where ideas simmer, blend and surface unexpectedly. Einstein called it combinatory play. Many breakthroughs come not from effort, but from quiet drift. This kind of thinking is passive, but not free. It still requires neural activity. It still consumes fuel, but it restores more than it drains. To imagine is to build a world, simulate others, invent possibilities, travel through times. See what isn't there. This uses the same systems as memory, language, vision, and emotion. Creativity is not leisure. It is neural construction, and construction burns fuel. So when your daydream feels tiring, remember, you just visited another universe. That's not nothing. It's the price of vision. Eventually, the system falters. Low energy leads to mistakes, mental fog, emotional instability, Poor judgment, memory lapses, your brain begins cutting corners. It stops forming new ideas. It reverts to habits. And that's when you need rest, not because you're weak, but because you are powerful and spent. Thinking is not free. And that's what makes it precious. Your brain weighs only 2% of your body, but consumes over 20% of your daily energy. Every neuron, every synapse, every electrical signal is built from nutrients you eat, digest, and absorb. Food is not just fuel. It's structure, signaling, memory, mood. What you eat becomes what you think. Glucose is the brain's primary energy source. It powers electrical signaling's synaptic transmission memory, consolidation emotion, regulation consciousness itself. The brain cannot store much glucose. It needs a constant supply, a sudden drop in you. Feel dizzy, confused, irritable, lost. Too much and damage begins. Glucose is like fire, essential, beautiful and dangerous in excess. 60% of your brain is fat, not as storage but as structure. Fatty acids create cell membranes, myelin sheaths, insulation signaling molecules. One type stands out: omega-3 DHA. It is crucial for infant brain development, supports memory and focus, found in fatty fish. Walnuts, flaxseed. Without enough DHA, synapses misfire. With it, thoughts flow like clean rivers. Your mind is not just electric, it is oily. Proteins are broken into amino acids, which form neurotransmitters, serotonin, dopamine. GABA enzymes, brain cell scaffolding, one example. Tryptophan gives serotonin, gives mood regulation. Another. Tyrosine gives dopamine, gives motivation. Your mental state can be traced to what you had or didn't have for breakfast. Thought is a chemical symphony, and food is the composer you need. Iron, oxygen transport, myelinasync, neuroplasticity, memory, magnesium.com, focus, sleep, vitamin B12, mood, nerve health, folate, cell division, emotional stability, iodine, thyroid function, brain development, vitamin D, mood, immune, brain communication. Each micronutrient is a key. Without them, the brain doors stay closed. Deficiencies don't just affect the body. They echo in mood swings, brain fog, fatigue, anxiety, depression. Mental health is, in part, nutritional health. Your gut is more than a tube. It is lined with 500 million neurons connected directly to the brain via the vagus nerve, home to trillions of bacteria. Your microbiome, microbiome produces neurotransmitters, strains your immune system, affects mood, memory, stress, and clarity. What you eat shapes the gut flora, and the gut shapes your thoughts. The gut is often called the second brain. But in truth, it is the first partner. Ever felt calm after soup, agitated after sugar, clear after greens? It's not imagination, it's nutrition shaping. Blood sugar stability, inflammatory cytokines, neurotransmitter levels, hormonal responses. Fast food may comfort, but it clouds. Whole foods may seem slow, but they sharpen. Mood isn't just emotional, it's metabolic. Poor diet triggers systemic inflammation, which crosses into the brain, disrupts neurotransmitter balance, alters stress response, reduces synaptic plasticity. Inflammatory foods, excessive sugar, processed seed oils, trans fats, artificial preservatives, brain fog, depression, memory lapses. These can be diet-driven fires, and the antidote is simple: real food, clean food, living food. The hunger hormone ghrelin rises before meals, but it doesn't just make you crave, it also enhances memory, increases attention, stimulates learning circuits. Why? Because in evolutionary terms, hunger meant survival, required alertness. The body sharpens the mind to hunt clarity, but prolonged hunger reverses this, causing mental collapse. Balance is key. In children, nutrient deficiencies lead to irreversible cognitive impairments. Iron, iodine, protein, and fat are foundational. Junk food distorts neural development in adolescence. Sugar overload can rewire reward systems. Omega-3 south support emotion regulation during hormonal turbulence. Adults, stable energy, hydration, and micronutrients maintain Mental sharpness, the developing brain, is sensitive, plastic, and hungry, and what we feed it shapes the world it creates. Meals are more than nutrients. They are rhythms, social patterns, emotional resets, sensory grounding. Eating with presence slows stress. Chewing mindfully engages the vagus nerve. Cooking evokes memory, creativity, and identity. Food is psychological architecture, not just fuel, but form, paradoxically. Not eating for short periods can boost brain function. Fasting triggers ketone production, autophagy, cell cleaning. Neurogenesis, BDNF, brain-derived neurotrophic factor, historically. Fasts created stillness, spiritual clarity, heightened awareness. Today, short-term fasting is being explored for depressional Zimmer's fog, but extremes are dangerous. Balance is nourishment. Modern food is engineered to hijack your brain. Hyper-palatable combos of salt, fat, sugar, dopamine spikes without nutrition-reinforced reward loops, cravings that mimic addiction pathways over time. The brain loses sensitivity to natural pleasure, flexibility, in mood resilience, in stress. Asterisk cravings aren't hunger. They are chemical echoes, and awareness is the first cure. Every bite sends a signal. It says, build me, come, fuel me, change me. Nutrition is not static. It's instructional. Your body is not a storage locker. It's a conversation between molecules and mind, and the brain listens to food like language. You lie in bed. The room is silent. The lights are off, but inside your skull, riot. Memories, worries, hopes, regrets. Imagine futures. You are resting, but your brain is not. Why? Because thought is its default. When you are not doing anything, not focusing, not solving, not moving, your brain does not go blank. It activates what neuroscientists call the default mode network, DMN. This network includes medial prefrontal cortex, posterior cingulate cortex, angular gyrus, hippocampus, and it revisits the past, simulates the future, constructs identity, generates internal dialogue, wanders. Emotionally and imaginatively, it's the mind by itself, with no task. But it's not quiet. It's chaotic. Your brain was not built for peace. It was built to predict where danger might come from, what the next moment may hold, how to survive tomorrow. Others might do or say even in silence. The mind rehearses. It runs simulations, tests possibilities, anticipates outcomes. This is exhausting. But it kept your ancestors alive. The modern mind inherited the ancient worry engine. When we stop doing, we hear the echo of accumulated thoughts, the unprocessed emotions, the unfinished loops, the what-ifs and should-haves. Because the brain is a storyteller. Stories hate being incomplete. This is why the moment you stop scrolling, stop talking, stop moving, the stories return, even if you don't want them to. Overthinking is not in sight. It's inertia. It often looks like repeating the same thought, tantalizing every word you said, playing conversations, imagining negative outcomes, worrying without solving. This isn't awareness. It's the default mode on overdrive. The brain's stuck in loops, not because you're weak, but because you haven't told it to rest. Much of your inner dialogue is imagined social rehearsal. What they might say, what you might say, how might react, what you should have said. This isn't random. Humans are social creatures. The brain evolved to track relationships, status, and connection. So when you're alone, the brain keeps simulating others. Thinking becomes a crowd. You cannot will your brain to stop. Why? Because thoughts arise from unconscious processes. They bubble up from memory, language, emotion, desire. By the time you notice a thought, it has already begun. The brain is not a faucet. It's a river, deep and old and flowing. You can't stop it, but you can learn to float. Some thoughts feel like noise. Others like knives, intrusive thoughts, anxious loops, shame spirals. These aren't signs of madness. They're maladaptive prediction systems. The brain is trying to prevent pain, avoid future danger, make sense of trauma, but it misfires, and it keeps looping until it believes the problem is solved. But some problems aren't meant to be solved. They are meant to be felt and released, even in sleep. Your brain keeps going. Dreams are the default mode in disguise. Emotions without context. Stories without logic, memory fragments, rehearsals you think while sleeping. You just don't call it that. The restlessness is simply repackaged. You cannot stop thoughts, but you can soften your relationship to them. Some quieting tools include mindfulness meditation, noticing thoughts, not becoming them, breathwork, giving the brain a rhythm to follow, writing, letting the thoughts leave your body, sensory grounding, shifting attention into the body, mantra repetition, occupying mental space with gentle structure, compassion, treating thoughts as frightened messengers. These don't kill the noise. They'll change your distance from it, and that space is peace. In silence, the mind panics. No input. It creates its own. The brain evolved in a world where stillness meant threat. Why? Is it so quiet? Did the predators leave? Did I miss something? So modern silence, no phone, no screen, no conversation, feels unnatural to the old mind. But that's where healing lives, because only in silence can we hear the parts we've ignored. There's a reason the best ideas come in the shower, on a walk, during rest before sleep. It's because the default mode is active. The 8. Brain makes novel connections. The ego is quieter. The unconscious speaks. Your restless brain is not a flaw. It's a forge, a place where new thoughts are born. You just need to listen gently. The brain produces thoughts like the heart produces beats. But not every beat means panic. Not every thought means truth. Some thoughts are echospheres, habits, signals, fiction. You can notice them, name them, even smile at them, but you don't have to believe them. Believe in every thought. It's like obeying every cloud in the sky. The mind that won't shut up is the mind that wants to understand, wants to connect, wants to fix, wants to make sense of a strange world. It's not your enemy. At your fireplace burning day and night to keep you warm. The trick isn't to extinguish it. It's to sit beside it and watch it flicker without needing to control the flame. The brain is not a mirror. It does not simply reflect the world. It is a filter, a storyteller, a pattern maker from scattered noise. It predicts, organizes, categorizes, interprets, creates order. It doesn't ask what is, but what does this resemble? You don't see the world. See the world interpreted through memory and memory. I love patterns in the ancient world. Recognizing paw prints could mean survival. Noticing a twitch in the grass could prevent death. Hearing repeated bird calls could signal danger or food. Pattern detection was life-saving. Even false positives were. It's better than missing the real thing. It's better to wrongly see a face in the bushes than to miss the predator hiding there. Your brain evolved to over-detect meaning, because meaning meant safety. Ever seen a face in toast? A smile in a car grill? Eyes in tree trunks? That's pareidolia, the tendency to see familiar patterns, especially faces where none exist. Why faces? Because the human brain has a dedicated facial recognition system, the fusiform face area. It activates even for imagined or symbolic faces. We are wired to see other humans even in clouds, cracks, and moons. We would rather imagine a company than endure randomness. When the brain finds a pattern in random data, a coincidence, a sequence, a connection, it's called epopony. This includes conspiracy theories, gambling superstitions, seeing omens and numbers, believing unrelated events are linked. It's not always a flaw. It's the brain doing what it does best, making sense. But sometimes, in its search for order, it invents chaos. Pattern detection happens across several brain systems: visual cortex, extracts shapes and lines, temporal lobe, identifies rhythms and repetition, prefrontal cortex, makes predictions, hippocampus, stores recurring sequences, basal ganglia, links actions and rewards from music to mathematics. From habits to handwriting, every repetition rewires the brain. The more a pattern repeats, the more real it becomes, even if it never was. Language is the most powerful pattern humans ever built. It takes vowels and consonants, syllables and pauses, grammar, in tone, context, and memory, and assembles them into worlds when you speak or listen. Your brain predicts the next sound, decodes, structure infers, intention seeks, emotional patterns even. A poem like this script is a pattern spell. You feel safe when the rhythm returns. You feel moved when it breaks. Language is music, and music is memory made repeatable. Why do certain songs feel so right? Because your brain loves structure, rhythm, key, meter variation, melody, harmony, tension, and release expectation, and surprise. Every song is a balance between I know what comes next, and I didn't expect that. This dance between order and deviation is cognitive delight. Music is patterned, motion, and the brain loves every note of it. Your thoughts aren't the only patterns. Your actions are too. Habits form when a cue triggers action, a routine unfolds. Reward is given, repeated enough, and the brain stores it in the basal ganglia, freeing up conscious effort. Habits are efficient, but they're also sticky, because the brain clings to what? Repeats, whether helpful or harmful. You are what you do again and again. Chaos makes the brain uneasy. In randomness, there's no prediction, no control, no narrative. It triggers anxiety, hyperfocus, mental fatigue. The brain searches harder, builds imaginary connections, even dreams and patterns to soothe itself. Randomness is real, but the brain rejects it, not because it's wrong, but because it's unsettling. The brain defends it. Confirmation bias is the tendency to notice what confirms your belief, ignore what contradicts it. Because new patterns are metabolically expensive, the mind prefers familiarity, certainty, coherence, even at the cost of truth. You are a storyteller. Your entire identity is built on narrative, where you came from, what you believe, who hurt you, what you want, who you are becoming. Stories are the brain's favorite pattern. They have beginning, middle, end, cause and effect, meaning and resolution, even. Your memories are edited to fit the story. This isn't deception, it's compression. It's the mind making too much into just enough. Sometimes you see ghosts and coincidence here. Intent and noise find meaning, and tragedy invents stories for chaos. Patterns can help or harm. They give hope or trap us. The trick is not to stop seeing patterns, but to question their truth. What's real? What's a reflex? What have you built from fear, and what is the fact? Despite their danger, patterns soothe us. They are predictable routines, familiar voices, daily rituals, songs we know by heart. They tell the brain, you are safe. You know what's next. You belong. Patterns are not just knowledge. They're comfortable. And when the world feels too big, they bring it down to size. Your brain loves patterns not because they're perfect, but because they mean something. From stars in the sky, to songs in the soul, to thoughts in the night too, are made of rhythms. And those rhythms are how the cosmos whispers back. If this story calmed you, sparked curiosity, or offered a sense of quiet, awe, then let it stay with you, like the gentle hum of your brain. Dreaming in silence as you stare into the stars. If you enjoyed this journey through the deep fire and quiet cosmos, consider subscribing or just coming back, because the quiet cosmos is always awake, even when you're not. Good night, Fire Watcher, and sleep safely.